In this video, we're presenting DeepSVG, a deep generative neural network for images in vector graphics format. An SVG image is defined using a set of shapes, curves, and lines, as opposed to raster images, which are drawn on a grid of pixels. Most research in computer vision focuses on raster images, which lets the task of generating SVG images directly largely unexplored. We propose a novel method to tackle this ambitious problem. DeepSVG learns deep representations of vector images using an encoder-decoder architecture. Once trained, this enables for generation, interpolation, and even latent space algebra, all of this directly in the SVG image format. We encode an SVG shape using its internal description as a sequence of drawn commands. Every command is mapped to an embedding space using the combination of its index in the sequence, the command type, and associated coordinates. The decoder then predicts the probability distribution of each command type and coordinates, from which we obtain the output SVG shape. While this approach works well for single shapes, what happens when encoding a complex SVG? We could just concatenate all shapes into a long list of commands, but this creates an ambiguity regarding the shape order for arbitrary complex icons. We propose instead to mimic the hierarchical nature of SVGs in our architecture. We therefore encode every shape separately and feed the encodings to a second encoder, which computes the global latent vector. We show experimentally that our approach leads to smoother interpolations and more meaningful representations. To train our model, we introduce a new large-scale dataset of SVG icons, which we call SVG icons 8. It is composed of 100,000 high-quality icons, and we make it available along with our code. Once DeepSVG is trained, we can perform interpolations of SVGs by linearly interpolating their encodings in the latent space. We can interpolate between random pairs of icons, or create animations by interpolating between two user-drawn keyframes. Finally, we show that DeepSVG can perform some latent space algebra. For instance, what happens if we compute the difference between the encodings of squares and circles and add or subtract this vector to an arbitrary icon? Well, it squarifies or roundifies it. Similarly, by removing the bottommost path of SVGs and computing the difference, we obtain a vector that represents the operation of adding a path. Here's the result on two icons. Our code repository is available on GitHub, which includes the dataset, training code, and pre-trained models. We've also added a graphical user interface to try interpolating simple icons on your own.